y'all. It's Dr. Know-It-All. I am with Dr. Scott Walter yet again today to talk about Tesla's Valentine's Day gift to all of us, which is all about robot dating. So this should be very exciting. Scott is going to teach me all about factory robots and the ins and outs of them and stuff that I don't know about. Anyway, welcome, Scott. It's good to see you again. We've got this
Same, Johns. Welcome to see you, and thank you for deciding to straighten me out on my misinformation on Transformers.
Well, you're going to have to straighten me out because, of course, I watched this advertisement, this for fun ad. And I didn't know that there were some very factually incorrect things. So without further ado, let's go ahead and watch the video through once, and then you can have me scroll back and stop on specific spots. So let's go to this spot. Okay. Hopefully this will share sound. Let me know if it doesn't. You can see that, yeah?
Yes.
All right, here we go. I want to stop on one thing before we even break it down too much, because we're actually in this ad.
I was going to say
I am.
That I thought you were on the Optimus. I was going to bring that up, that we're Optimus is
right here.
Are you in the front row?
Like the second or third row back, so somewhere in this,
somewhere in there
over here.
Yeah,
so I was like, I'm in this, I'm in it.
But the video quality is so bad, I guess purposely, to be like some cheesy 70s video or something like that. But
and then you have those
details.
Really fake computer voices from back in the 80s or something.
Can you make that full screen so we can get well, it's hard to say. I mean, the resolution is just going to get even worse when we blow it up.
It's pretty bad.
But I know you're in there. Yeah, you're over there somewhere.
I'm in there somewhere. Wait, let me do it this way. Let me do theater. There we go. That'll make it bigger. But anyway, it's somewhere like right around above his fingertips is where I am. So somewhere. So anyway,
now we're actually not going to talk about Optimus. We're going to talk about all the other robots.
Yeah, all this Optimus stuff, except for this. This is the only thing that's new that I hadn't seen before, because of course that's a POV shot.
Yes.
But everything else is stuff that we've already seen with just funny.
Seen and discussed at end. Yes. Yeah. Okay.
So anyway, very cute idea. Whoever came up with this, it's adorable. I love it.
Right. Okay. Now, the first thing, John, you want to explain the very first dad joke here?
The articulate one?
Yes. The
Johnny says that he's articulate or well articulated or something.
Well articulated. And actually, I missed that myself, because articulated robots are articulated.
Right.
That's what it means, is you get the jointed arms in there. And I was like, oh, it's funny. He's saying he's well articulated. And I forgot that it goes back into that someone who's well spoken is also well articulated.
Right.
So that was the dad joke that was going on there. However, can you tell me the robot brand right off the cuff? Can you, by looking at that?
The red ones are, oh gosh, okay. Is it Fennec that's the red? Or is it there?
No. See in this case.
Oh, this is Tesla red though. They just painted
this. Is Tesla red. Yeah. Normally you can tell the robot brands by the color, but Tesla wants them to be Tesla red, so we can't tell.
Right.
And at first, I didn't realize that these were not Kukas. These are Fennecs, and you can tell Fennecs a couple of ways. One by the motor drives that are on there. Okay. So that's very particular. You can sort of see that, and also it's badged a little bit. You see that upper arm with the yellow nameplate on there.
Yes.
It's out of focus, but in a couple of them it comes in. You'll see it's like the Fennec 2000 IC. So we're going to notice that. Probably not here, but in one of the others. But those are definitely Fennecs.
Okay.
Yep.
But then the one you really wanted to talk about was Joey 2000.
This one here, yeah. So pause this one. Now this is definitely a KUKA. It does actually say KUKA on there, and I recognize it also just from the shape of the motor drives and everything else.
Right.
And so we go along here.
Let's see. I was just waiting for this to. So this.
Yep.
A bunch of people thought this might be part of the Cybertruck or something like that online.
We're going to come back to this. So we're going to do what we normally do. We're going to take a 30-second video and turn it into 30 minutes probably. So here we go.
So there you go.
All right. So let's go
and
ahead.
When we get done with that, we're going to talk about this. So
this, yes. Yeah, so that's going to be fun. Okay. Now, so you just kind of run it along and you're going to see.
I've got the sound off now, by the way, so you can talk over it.
So we now have, okay, he likes working out and can lift 40,000 pounds. Now, when I first saw that, I had to like stop for a second, say 40,000 pounds. And like, wait a minute, there's, first I know that robot can't. And I was trying to think if it was even close. And that is like off by an order of magnitude. So my concern is that a lot of people will look at this and think that there are robots that can lift 40,000 pounds. And no, they can't. All right.
Okay.
So, usually the robots are spec'd in kilograms. So if you divide that by 2 or 2.2, whatever you're going to do, you're talking, somewhere around 20,000 kilograms, which is a lot. Okay.
Right.
The biggest robot, and I think it's been, they call it Godzilla, and they did show it, I think, in Berlin. And this is the robot that picks up the whole car body and puts it around there. This is the FANUC robot. It's also a 2000 class robot as far as like what the way they put it in their model numbers, but it's really big. And
is that the one that we saw at Giga Texas when we were there? Did we see?
I'm trying to think if we saw that at Giga Texas or not. It may have been there as well. So when that first
came out, big. I remember it was a very large robot, and you were like, "That's a big boy."
It's always been very big, and I think when it first came out, it was one of the first robots to be sort of over 1,000 pounds. That was like a 6-axis articulated robot, and it was designed to be able to take from one conveyor to another or to lift it up. And then later on, it was like, well, we want you to actually do it with an engine in there and a transmission, the whole car body. So they up the payloads. The payload's now like 2,300 kilograms. And so if you multiply that by 2.2, that gets you around 5,000 pounds. That is the upper limit.
Okay.
Right? That's the biggest. Now you might have like some Cartesian robots or some other specialty robots that can also be around there, but that's really, really high. The biggest KUKA is 1,300. That's the Titan, and this is not a Titan.
Right.
So the biggest KUKA is around 3,000 pounds. Okay, so we can say that Joey is definitely a fabricator. That's my dad joke. Okay?
Speaking of dad jokes,
that's my. He's quite the fabricator there, in making that up. So not even close. Now the question is like, well, what is the payload of this guy?
Right.
And it's a little bit tricky to tell because. The payload is going to depend upon the servo motors, the kind of control system you have in there, and a few other things. But this is your standard articulated arm that doesn't have any special kinematic arms or other linkages on there to give it strength. So there are these 4-axis robots for palletizing that pick up heavy boxes and stuff like that. And they can also be in a payload class of like 900 kilograms, 1,000. But it's because they've got all this special extra linkages to give them that strength. And this is really coming from the servos, and you have to have a really strong wrist to be able to handle something like that. So this here, I'm suspecting, is somewhere around 420 to, it's probably under 500 kilograms. And I can show you why. I can show you
so just for reference, because whatever this side panel is, or whatever this thing is that it's lifting, is probably on the order of 400 or 500 kilos, or is it less than that?
It could be. So let's kind of break it down. The first thing you got to remember with payload is payload also includes your end of arm tooling. You don't get the tooling for free.
Right, that's true. And everything that's colored red is tooling.
And even the dress package you've got to throw on the robot kind of becomes part of it. But yeah, that's the tooling. And normally a spot welding robot is 100 kilogram class, meaning 100, 120, 150, usually around there. And that's because you're depending on the size of your welding of the spot welding gun, it will be around 100 kilograms. That's easily twice the size of a spot welding gun.
Right.
And I would think there's a lot of metal there, and so we're already looking at close to maybe 200 kilograms just there in the end of arm tooling. And then you've also got the payload itself that you're looking at. So you're probably having to push close to 500 kilograms there. Looking at this, I think that is two castings, front and rear,
Okay.
and then you've got the side panels that are
Because
holding
of
it together.
this, the thing on
Yeah,
the right.
that
Yeah.
looks like a casting. In the back, I think that looks like a casting too. I don't
Okay.
think so. That means it's probably not the Model 3 yet. I know the Model
Right.
3 is going that way. So it means it's probably the Model Y,
Yeah. Okay.
because I don't think the S and X have the castings yet.
Okay.
And then you've got some sort of side rails here, which I think that, that's where the battery pack is going to mount in. Now, this is not with the structural pack, because I think the idea of the structural pack is that you mount it directly to the castings. There is no additional structure that you
Right.
drop it in.
Unless these are temporary, these beams on the side could be temporary.
They
just to hold
could
it
be
in
temporary
place
to hold it in place.
until you
It could
drop it
be.
in.
It
Yeah,
could be.
yeah.
Now the suspicion is that this is probably Fremont. So this is why we're try to debunk.
Oh.
A lot of people thought. I think it's, and the reason I think it's Fremont is that when we were in Austin, how many KUKA robots did we see?
Oh gosh.
We didn't see any.
Yeah, they were all.
We saw FANUC,
Yeah.
and I've seen like the drone fly through that they did of it. It was not
Right.
showing any either. So
Right.
it seems like KUKA's kind of reign in Fremont, not so much in Austin.
Right.
So over around here, because you're seeing that, my suspicion this is probably in there. This is definitely the body shop. If you go back to the very first one where the spot welding was going on, I want you to notice
this guy?
the ambient. Yeah, go back to the very beginning. When this is running along here, I want you to look at the ambient lighting just back there. Do you see anything, any flashes, any sparks, anything like that?
No.
When you're spot welding, there better not be. You will see videos of these plants with spot welding, and you see these sparks going around, stuff like that. That's all for show. A lot of times when they have some VIPs coming through, they will crank up the voltages on these things. So when the robots are spot welding, they're doing it. Whenever you see a flash like that or sparks coming off of a spot weld, that is a bad spot weld. You do not want to buy the car. Okay. So if you're getting that, there's something wrong. They need to go and touch it up. You do not want to see it. So when you're doing spot welding, occasionally you might see some little sparks and like that, but nothing else. But if you go to this next one, I want you to look around up in the ceiling.
Before we do that, I was going to say the ceiling does not look like Texas.
Doesn't look like it. Doesn't look like Texas. Nothing there really looks like Texas. Right. So if you run it, you're going to see a lot of blue light in the background that's kind of flickering a little bit.
Yeah.
When you get in there.
Oh, yeah, back there. Like as if
you see all that? You see all that?
Yeah.
That's arc welding going on there. So that is probably like the body shop.
Right.
Which means a lot of what's going on there
too.
Yes, is probably being done with arc welding and not with spot welding.
Gotcha.
So they're doing something to marry the castings together with whatever is the center for the battery module there. That's my suspicion. What's really interesting is the way they do it. Okay. And the way they're doing it is it's kind of using an analogy. When you have a wood shop, you usually have a table with some vices and a few other things and some clamps. And when you build something, you pick up your parts and you put them down there and you clamp them on the table and you do whatever you do. When you're done, then you pick it up and take it off and you put the next one on there. That's the same way that happens in a lot of the body shops as well, that when you want to build a lot of these sub-assemblies, you have a fixture table that's set up for it to accept all these different parts, and they're either fed in manually or robotically or something like that, but they're put in, you close the clamps down, it's held in place, you go in, you then weld them together or do whatever to adhere them together.
Right.
And then something, either the human or robot comes over and then picks it up from the top end and pulls it out. Okay. So usually that means you've got clamps on the bottom and kind of some clamping mechanism at the top has to come and take that thing out. Now, there's reasons why you may want to do that for overall efficiency, but it's additional cost, that the fact that you have all these different systems that have to like pick up and grab and everything else. There's this concept of jigless welding where they actually want one robot to go over and hold the whole thing together. So in other words, it is in a sense holding onto the table, and then you put all the parts on there, you do all the welding, and then when you're done, the robot moves somewhere else and drops it off. Now you notice it's making a really long move here. It's going along what's called an RTU, which is a robot transfer unit. Most people just call it a track. So that's a 7th axis, which is kind of moving it along. So it's taking it from that station, getting it out of that station, and now the transfer is coming over here. And of course, they cut off what is going to be the most interesting bit here. It's getting around, and I think it's getting ready to flip it 90 degrees to put it on a computer or some other station, because it's holding it. It's the station is upside down right now. If you look at the body, it's upside down.
Yes.
It's picking it from the top. So now it's going to probably see right the way it is right now. It's getting ready to do a flip like that.
And you can also see the way the arm is articulated. It would make sense. It would be able to do that too.
Yes, exactly. So that's the fifth axis of the wrist is up. All it needs to do is go.
That's impressive down. With that much weight that it's able to just.
Well, that's those wrists. That is the key to being able to handle a heavy payload. It's not the first three. You need to have a pretty strong wrist for that. So it's going to come around and it's going to drop it off, and then it's probably going to return and going to do the same thing. There are advantages and disadvantages. While we're doing this, the other parts cannot be brought into the cell. There is no jig over there. So depending upon your throughput, unless they're doing some other little tricks there, unless they have like 2 robots that are doing it on both different sides. But it's a rather interesting approach. So I think they're using jigless welding here. It also is interesting when we saw it pick it up, it was at like a 45-degree angle, and it doesn't look to me like the robot can stretch any further or even make it horizontal without the robot self colliding with it. So
yes,
I'm kind of wondering, see right there. So it almost seems like they're assembling it at about a 45-degree angle for whatever reason. And then maybe these other robots are coming around there, and you see that orange shield there. Oh, or is that a screen? No, that's a screen. Okay.
Yeah.
Sometimes when you see, I think that's a screen. A lot of times you'll see this plastic or well, you do see orange shielding down. There's definitely a lot of orange shielding. That might be a reflection we're seeing.
Right.
Usually that's what they put up there to block you from the arc that's coming.
Gotcha. Well, I think you can definitely see through this partially because you can see the body.
You can see through it. I think we're seeing a reflection of what almost looks like a monitor there. That's why for a second I thought it was a screen. But yeah, that's just going to be safety protection to make sure people's eyes, you don't get what they call arc eye, because the arc welding is producing a lot of ultraviolet radiation.
Right.
If you look straight at it for too long, your eyes go kind of crazy. So so there's definitely probably
you can also like one thing I also noticed is that this is pushing the tolerances of the ceiling. Like it's hard to tell, but it's getting reasonably close
the ceiling's still up pretty high. It's still good. Usually those ceilings are pretty, it looks like it, but no, that ceiling's way up there.
Yeah, okay.
But yeah, it is getting up. So
it's up there.
Yeah, I think they have, well, yeah, you gotta remember this is Fremont. So it's I think when they built the next ones, they made sure they had a lot of vertical, but yeah, I think they have enough clearance to bring it around.
Right.
So sometimes I think it's intentionally blurry just to make sure we don't pick up too much detail. Because the one thing I'm wondering is whether the robot has something at the end that allows it to actually mount to that fixture to do a quick swap out, or I think I think it's kind of permanently attached. In other words, they don't have a swap out mechanism for it. So my suspicion is it's on there, and that's just how it goes. That's the reason why you'd want to have a table, because when I remove this from the table, as soon as I'm gone, the other robots are just sitting there just waiting to pounce and come in and drop the stuff in, close the clamps, and let the other guys go. Because usually you have 49 seconds to do the whole cycle. Okay. And when you start going above that, you don't like it. So there could be a lot of wasted time trying to get that over to do the transfer and drop it off, and then try to get back.
Okay.
But it could be other things going on that
you as far like what happens right before this is that these parts are placed onto this.
They're probably placed on there by
receiving some unit, and then they're welded together so that they're there, and then it brings it up, flips it over, and drops it so it can move on to the next station.
It drops it onto that. That's what it looks like to me. Yeah, that's
but that does mean unless there's 2 robots working, the entire time that it's doing that flip maneuver and going back to get restocked, that's wasted time, right?
That is wasted time, but that could also be the time that those robots have to go over and pick up the castings. Now,
that's true,
to kind of bring them in, and then there's the robots that are doing the welding. So I'm pretty sure the robots that are doing the welding and bringing those castings in place are different robots, because arc welding robots have notoriously low payloads. I mean, we're talking, 10, 20 kilograms, and you need something that's probably, 7,500 kilogram payload at least to be able to bring those castings in.
Right. And just to replay this again for people
to watch, tooling to be able to do both. Yeah.
Right. To watch the background, you'll see the blue flashes right back there, and other places where you can see flashing.
You see it kind of strobing as it's going along. I mean, that's what that's a classic thing you see in any sort of welding shop.
Up in this area, for example.
Yeah. It's all over the place. Yeah. I mean, and this is kind of the fun forensics that you can have looking at something. And I'm sure there's thousands of clues that I missed that someone else will pick up in the comments, like, didn't you notice this? Didn't you notice that?
Well, again, part of the problem here, of course, is this is intentionally, probably just for the joke of it all, is very, very low resolution.
It could be dual purpose. Remember, everything with Tesla is dual purpose.
Yeah,
one
that's
is the
true.
joke, and second is like, don't give up too much information.
Right, exactly.
So, they make sure, don't show the 5 seconds before and don't show the 5 seconds after. It's like, that's all you can show, and make sure it's blurry.
The hysterical part for you in particular is that I've talked to a bunch of Tesla employees who watch you figuring stuff out on their part, and they're like, damn, he's good.
Which
so
maybe that's why they keep dumbing it down.
He figured that out. We intentionally
don't release that. Yeah. He showed too much.
If Scott can figure it out, we got problems. So anyway, but I mean, I guess to go with the joke of him lifting 40,000 pounds would be the classic exaggeration during a dating profile.
It's quite the exaggeration. There's no robot that could do it. I mean, if you want to do a quick screen share, I can kind of show you what the different robots look like. So you have
sure.
an idea.
Yeah, hold on. Let me stop my end.
Yep.
Okay.
And let me go ahead and get my screen up here. And then,
wow, after looking at that blurry for so long, you look very crisp. Isn't that nice? I've been staring at that blurry image for too long.
Yeah. Okay, can you see this?
Yes, I can.
Okay, so this here is the Godzilla robot. That's the FANUC robot, which is able to do 2,300 kilograms.
Gotcha.
Okay, this is the Titan class robot from KUKA, which is able to do 2,300. You may have ridden on this robot. There is a 4-axis version of it where they actually take 2 of the axes off the wrist. They have one over on there, and that is what does the ride at Harry Potter World in Universal.
No way. Wow.
Yes,
I have not personally, but I know what you're talking about. So
there's something out there called the Robo Coaster, and it's based on this, the Titan robot.
Wow.
You just don't see it. It's all covered in black and everything else.
Right.
These others are kind of different payload variations of almost the same arm. And of course, we're seeing the arm basically from this side. And a lot of times you have these big counterbalances and backlinks and stuff like that allows it, just like an elevator will have a counterweight.
Right.
If you want to lift a lot, you got some counterweights here. And so these are the extra weights that get these things over the 500 kilogram. This is like a 600 kilogram. This is a 500. And now we're getting into like 480 and 420. I suspect it's probably this one here because it's the arm is a little bit shorter than this one. And the longer the arm you have for that reach, your payload drops immediately because of that moment arm. Yeah. If you have the same servos and everything else. So that's why I'm guessing it's probably this one. Then you get kind of an idea of what they are and how they come in. So this is the one that's big enough to pick up a car. And I mean, you see that wrist is like, that is quite a cool looking wrist, just to be able to handle it. And,
so
these are also pretty.
Which one is the
big
Joey?
bulky,
which one is the Joey 2000 that we're?
I'm guessing it's this one right here.
Okay.
And none of that's hidden. So that's like the 420 with about a 3-meter reach. That's my guess.
Gotcha.
Somewhere around there. And it's on an RTU, so it's on a track that allows it to slide. It's the 7th axis that makes this pedestal move back and forth.
Gotcha.
And there's different versions of these robots to hang from the ceiling and hang from the walls. These are usually called the pedestal mounted or floor mounted robots. And then you'll see that they have a variety of different versions depending upon how it has to be used and put in.
All right.
That's cool. But that was my guess, just kind of going through the catalog and taking a look. And sometimes it's better to have a picture than us just describing what it looks like.
Yeah. And again, obviously painted the Tesla red in the case of this thing. But the interesting thing is the amount of that tool mount thing that it's got on the end of the arm has got to be a pretty heavy, substantial beastie that it's swinging around there. So,
and it's got a big moment arm on there as well.
Yeah, exactly.
So the moment of inertia for rotating that is quite a bit.
That's one of the things that's really impressive is assuming that that's real-time motion, that thing's actually moving at a pretty good clip. I mean, it's picking it up and, slinging it around. No problem.
Now you can sometimes exceed the payload that's there, but you have to go really slow.
Right.
So usually when they talk about the payload, the rated payload would be at a speed of, at least 2 meters a second.
Right. Gotcha.
1 to 2 meters a second for sure. You don't have a payload like that and just want to creep along really slowly. You want to get something done. Right. Of course, we don't know if that's been sped up or anything like that, or slowed down, or from the video. That's possible.
Gotcha.
All right, I'll stop the share, and I
Sure.
think that's enough chatting from me.
Okay.
Unless there's anything else you wanted to see in that video. I mean,
The only other thing was
identify the other video, the other robots that were in the video, just for the fun.
Yeah, let's just go back real quick and just touch on. I'm going to split this into two actual videos, by the by. It's going to be too long otherwise. So we're just going to spend this video talking about robots. But obviously Optimus, we've got Optimus, and you know, that stuff we've all seen and talked about before. But let's see. The next one is J2000 here. So I don't know.
Now this is
like it moves really fast.
Can you tell the robot type? Well, it tells you right there.
It's moving really fast.
It's moving really fast. There was for a second there. If you just go back a couple of frames, it will reveal itself. It's the only image that's not blurring.
Yeah, it's just hard to catch it on that frame. YouTube is not fantastic about frame accurate motion.
Yep.
So I don't know what was that guy. I couldn't see.
So as we run it, and then
there it is. It's a FANUC.
Right there. Stop. There you go. The FANUC. Yeah, the R2000 IC.
Yep. There we go. Cool.
And the 2000 has nothing to do with a payload. Usually they don't have a slash after it that would say what the payload is. It's probably like a 175 or a 225 or something like that as far as the payload. But the R2000, I think, is something to do with kind of the kinematic style they have, because the big Godzilla robot is also a 2000. Right. And then it's like, but it has nothing to do with the payload.
Gotcha. So what is the payload on this? That is weird looking stuff.
It was hard for me to tell. I mean, like usually when you see something like that, you say, oh, that looks like an engine casting. You realize, oh no, that's not, you know, it's Tesla.
It's just weird. It looks like it has two little baby wheels on the side or something odd like that. I don't know.
Yeah, whether it's for opening or closing the style of the gripper, whatever it's picking up or manipulating, it's very hard to tell what that is.
Yeah. It's fast though. Whatever it's doing, it is fast. That's really cool.
Yeah, he likes sailing along. That's for sure. So I wasn't sure. Someone might be able to identify it. I didn't know if it would be something to do with like the motor housing.
Right. Right. Yeah, maybe it's just a housing or some sort of unit like
this
that.
One, you know, now this we can tell from the color. This is a FANUC.
Right.
For sure, where they didn't, and you can see the classic drives on there that tell you it's a FANUC, the black with the red encoders on top of there, and then the yellow. What this is doing, I have no idea.
Right. You know, it does look like it's ringing a bell. I mean,
yes, and why, I don't know. I mean, if it's to get the operator attention that like I'm out of parts over here or something like this, that's not how it works. You know, usually there's a signal that goes. It gets sent out.
Right. So, and I swear these look, I don't think the scale is right, but these look like tennis balls for some reason.
I know. I keep on thinking of tennis balls too. And it's like, they can't be tennis balls. It's going to be something else.
So that's very odd.
It is really odd. And I'm just trying to think, is it doing some sort of shake test? But yeah, it's like, all right.
Or, I mean, maybe this was just a for fun demo or something like that too. So I don't know.
I mean, I was thinking this, you know, sometimes, it could be that they just went ahead and did that. A lot of times you will have a training area for people to get trained on the robots. Right. And that's the other thing we can point out about the robots is, you know, why when you go into some of these different factories do you usually see one brand in there? And there's a couple of reasons. One is each robot has its own language. There is no common language in the industry. They're all similar, but their teach pendant's a little bit different. Everything about it's a little bit different. So when you have someone that really knows how to use a FANUC or KUKA, it's kind of hard to be bilingual on those things, and you want to get everyone trained up on that. Yeah, you can learn the other one, but you want to make sure if the factory has all this brand of robots in there, we know anyone in there can quickly go over and deal with an issue. Right. But a lot of times it's not as simple as a manufacturer saying, we just want exclusively KUKA robots, because you don't buy robots, you buy solutions.
Yes.
And you go to an integrator. So just like cars are sold through dealerships, a lot of robots actually go through the integrators. So it's the integrators that create the end of arm tooling, and everything else goes wrong. And they have like area expertise. And you'll say, well, we need a cell that does this. And they'll say, fine. And it's going to be this brand robot. And you'll tell them something else, and they'll say, fine, we can't do it. But there are other integrators that realize, like, if you want to work in the Detroit area, usually you make sure that you can deal with like ABB, FANUC, in KUKA, and maybe a Scala or something like that. And if you're Ford, maybe you're dealing with Kawasaki or Nachi. So they will make sure that they can kind of handle some of these others that are in there. And a lot of times it's because the OEMs will go out and make a huge purchase of several thousand robots over like a 5-year period. And then they just start giving them to their integrators to say, here, you know, you just kind of take them from there. You go ahead and make the solution for us. And that's what goes in. Gotcha. So Tesla was probably had some preference on them, but they had to deal with a lot of integrators. And if the integrators have no experience with the KUKA controller, they're just going to say sorry. But if they're really good at a particular thing, it's like, all right, then we have to have the FANUC in there.
Gotcha.
So that's why you'll see them mix a little bit, but they're going to try their best to try to stick with one brand.
Right, right. Which again is why probably the Giga Austin factory, at least from what we could see, was all one brand. So yeah.
Yeah.
Okay. Okay, and then the last one, just a real quick one here. We don't really see the robot itself, but TIE, which just looks like a seat testing robot or something like that. So
Yep.
Yeah.
Exactly.
So how would it, I mean, obviously it's pushing on the seat. Does it have sensors in it, or does it use some sort of
part of it could
or
be
something to determine like the quality of the seat?
But you're also doing the seat testing. So you've got to remember there are sensors in the seat anyway to make sure a person is sitting down. So you're going in and you just want to verify that all the electronics in the seat are working correctly. Gotcha. So you're just like, okay, let's just see if we and change the payload and stuff like that and make sure it's sensitive enough to whatever is the requirement.
And I guess with this, you can determine very precisely the amount of force you're placing on the downward back so that you can calibrate the seat too. So it's like, okay, we know that's 65 pounds of pressure or something like that. So,
right. Whatever it is, just because if you want the seatbelt warning light to go off and everything else, you need to test it.
Right. Yeah. Well, I mean, Tesla's even more specific than that because of course they have their whole airbag deployment thing based on how heavy you are, whether you're turned in the seat, things like that. So I would imagine calibrating this is pretty important.
And there could be other things just to see that the seat's able to sort of handle this kind of load without the stitching suddenly breaking open or something like that. That might be a quick way of revealing that. It's like, oh, okay, that's a seat that's not going to go out. Yeah,
little quality control action going on here.
Yeah, exactly. So
one thing that is interesting here is that you can see that there's a second. So it looks like the seats have already been mounted on their bracket so that you've got the two together. So it's not like testing one at a time. They're already like mounted and ready to go. So it probably does that. And then the other one. So
yes. Yep.
Very, very cool.
Yeah. I don't know if the center. Yeah. The center console is probably not in there, but yeah, you have some seats which will have the center consoles also in there. And that's the whole unit that's usually goes in.
Right. Yeah. I mean, honestly, this could be the structural battery pack because it looks like it's sitting on a deck down there. So that could be the deck that's the structural battery pack that it's already bolted onto and it's tested it before it sticks it up into the vehicle. Maybe. I don't know.
Might
not be either. Oh, you know what? No, this doesn't look like that because this is probably slots where it just drops in and moves forward.
It just drops in and holds it. Yep.
So that wouldn't be the structural battery pack. Yep. My bad. Wrong. I'm wrong. So anyway, cool. Yeah, I don't know if there's anything else you want to talk about with that video. It's kind of amazing how much, we've gotten about 45 minutes worth of fodder out of a little silly 1 minute. And we didn't even talk about Optimus.
Exactly. Can you believe that? It's like, nothing new there.
Seen it, done it, been there with the Optimus thing. But,
well, the main thing that came out of Optimus was like, the massage where there was like, wait a minute, is that an Easter egg that, that's what Elon's thinking of? And like, I'm not sure you can draw any conclusion from that.
I think it was just literally because they'd shown that picture of it doing that. And it looks kind of like a massage, it's like doing that little thing where it's like
now I'm pretty sure that it was not the Cybertruck frame. So
that would be. I wouldn't think Tesla would be like basically dumb enough to show. They have plenty of robots that are lifting up frames that people have already seen before. So I don't think. Anyway,
so we'll debunk that.
Yeah, there we go. It's unlikely. Maybe we're wrong, but I will. It looks very similar to what I've already seen with the Model Y when Sandy Monroe did the teardown and you looked at the inside, unless the scale is completely different and we're just not recognizing how big it is, but maybe it is lifting 40,000 pounds. That would make the Cybertruck.
That would be amazing.
Heavy, if it could lift 40,000 pounds. Heavy truck.
So robots cannot lift that much. Okay.
Yeah, there we go.
5,000 max. That's an order of magnitude exaggeration.
Yeah. All right. Well, thank you so much for doing this video with me. I hope people enjoy this trip down factory lane. And I guess we'll see you in the next one, which is coming up really soon, because we're going to talk about something else in just a minute, but we're going to split it into 2 videos. So for this one, I'll say bye-bye. Make sure you subscribe so you can see the next one.